Okay, so in this video, we're going to learn how to factor expressions in the form of x squared plus bx plus c. Meaning your first term is squared or has an exponent of 2. Your second term has an exponent of 1. And the third term is just a constant. It doesn't matter what variables you have. So you can see in this case I have x's here and c here. But as long as you have a squared term, your next term has an exponent of 1, and then your last term is a constant, you can factor using the method I'm about to show you. All right. And remember, factoring is just rewriting an expression as a product or factors or as like a multiplication problem. All right. And so the way we're going to set up our answers here, or our factored form here, is that you're going to write it as a product of binomials. And by binomials, I mean 2 terms. So in each set of parentheses, you're going to have 2 terms. All right. So I went ahead and just drew my parentheses to write my answers. And the way that you factor expressions in this form, you want to find 2 factors of c, or your constant, that has a sum of b. And that's it. And when you find those 2 numbers, you're just going to put them at the end of your binomials. So let's try the first one. Since my variable is x, I'm going to simply write x in my first as my first term in each binomial. All right. And so I want to find factors of 15 that equal 8, or that have a sum of 8. Factors of 15 are 1 and 15. When I add it, I don't get 8. Factors of 15 are 3 and 5. 3 times 5 does give me 15. But when I add it, right, I do get 8. So I could use 3 and 5. And I just simply take 3 and 5 and plug it in. They're both positive. So I just put plus 3 plus 5. And I have factored this, we call it a trinomial because it has 3 terms. And that's it, I'm done. But let's check it just to make sure. And of course we could check it by multiplying back through, since this is a product. And we're going to use the distributive property just to check it. All right. So if I multiply x times x, I get x squared. If I multiply x times 5, I get 5x. 3 times x, 3x. 3 times 5 is 15. Combining my like terms in the middle, because I can add them because they're like terms. 5x plus 3x gives me 8x. And I bring down my 15. So that does check out. And so I have factored this trinomial, or this expression, correctly here. All right. So now let's try the second one here. We have a negative. All right. So a little different. Since I have a c for my variable, I'm just going to put a c here. So whatever variable you have, that is what you will put in your final product. All right. So I want to find factors of 12, all right, that has a sum of negative 8. So since I have a negative here, I know that one of my factors, well, you know what? Not one of my factors. Both of my factors will be negative. Why? Because when you multiply negative times a negative, you get a positive. You cannot multiply a negative and a positive and get a positive. So looking at this information, I know that, okay, since my b is negative and my c is positive, my factors have to be negative, because that's the only way when I multiply I will get positive numbers, all right, or a positive answer. All right, so let's see. So 12, I could use 4 and 3, negative 4, negative 3. Will that add up to negative 8? No, that adds to negative 7. So that does not work. Let's try 6 and 2, right? 6 and 2. And they both have to be negative. right? Because when I multiply, I want to get a positive 12. So negative 6 times 2 gives me positive 12, right? But when I add them, negative 6 plus negative 2, that does in fact give me negative 8. All right. All this information you could do mentally. I'm just writing it out to show you. So think factors of 12, negative 6 and negative 2. I get positive 12, and when I add them, I get negative 8. So my two factors I'm going to use are negative 6 and negative 2. So since they're both negative, I'm simply going to plug it in, and it will be minus because they're both negative, and I have factored this trinomial. All right. I'll check this one as well. I'm not going to check the last one, but let's just go ahead and just check it. Different color just to separate. Well, checking it. C times C, C squared. C times negative 2, negative 2C. Go back, multiply negative 6 by both terms in the second binomial. Negative 6 times C is negative 6C. And negative 6 times negative 2 is positive 12. Combining my terms in the middle, negative 2 minus negative 6C will give me the negative 8C. And so that does, in fact, check out. All right. Last one we're going to do, and then you're going to try some on your own. So, factors of negative 28, let's draw a little T-chart, that equal or have a sum of negative 3. All right, so 14 and 2, no, that doesn't work. I know that there's no way I can get 3 from 14 and 2. 7 and 4. 7 and 4. Let's try 7 times 4. All right. That 3 has to be negative, so when I add it, I have to get negative. So negative 7 and positive 4. Negative 7 times 4 gives me a negative 28. When I add it, when I multiply it, but when I add it, do I get negative 3? Negative 7 plus 4. That does, in fact, give me a negative 3. So I'm going to use my factors, negative 7 and 4. So I simply plug it in here, plug in my x's, minus 7 plus 4. And that is my answer here. Keep in mind that it doesn't matter if you flip the term. So like here, I could write this as x plus 4 and x minus 7. Doesn't matter. As long as you have the correct sign with the correct term. But that is my final product when I factor x squared minus 3x minus 28. All right. So we have factored these 3 expressions or these 3 trinomials here. All right. So I would like for you to try these 3 or factor these 3 expressions or these trinomials on your own. Take note here that for your B term or your term with one variable, you just have an x, right? Remember that the coefficient of x is just 1, and you have it right here as well. All right, so factors of that last term, it has a sum of 1. All right, so go ahead and pause the video and try these 3 on your own. Okay, so hopefully you got these 3 problems correct. For the first one, x plus 1 times x plus 5, and again, it doesn't matter, your binomials could be flipped, okay? You should have gotten x plus 3 times x minus 2, or you could have gotten x minus 2 times x plus 3. Doesn't matter as long as you have the correct sign with the correct term, all right? And the last one, x plus 5 times x minus 4. All right, so I hope you got these 3 examples correct. Okay, so I want to just show you 2 more problems with factoring these expressions. If you notice here, you have a number in front of your x squared term or your squared term. All right. So one thing you want to do is always check to see if you have a greatest common factor between all three of your terms first. So right here, between these three terms, I have a greatest common factor of 4. So 4k squared divided by 4 leaves me with k squared. 12k divided by 4 is 3k. 8 divided by 4 is 2. All right, and so now we have our trinomial without a variable in front. All right, so or without a coefficient in front. So for now, I'm just going to leave that 4 alone, but I just want to factor what's inside right here. So 2 factors of 2 that equal 3. The only 2 factors of 2 are 1 and 2. And when you add them, you get 3. So my binomials are k plus 2 and k plus 1, or vice versa. And then I just bring down my outside number that I factored out. So my final answer is 4 times k plus 2 times k plus 1. Or again, we could flip those binomials. All right. One more. Greatest common factor, 2. I'm left with x squared. Negative 8x divided by 2 is negative 4x. Negative 24 divided by 2 is negative 12. Now I factor what's left inside. 2 factors of negative 12 that equal 4, or negative 4. Let's see. 6 and 2, right? So 6 and 2. 1 has to be negative. The 6 has to be negative. Negative 6 times 2 gives me negative 12. But when I add them, I do get negative 4. All right, so my 2 factors are negative 6 and 2. So x minus 6 and x plus 2. And then I just bring down what I factored out originally, that 2. All right, so these are just a little different because you have to factor out a greatest common factor first before you factor the rest of the trinomial. All right, so hopefully you understand how to factor trinomials, and thank you for learning with me.